Hi guys. So week number 10, and this is going to be lesson number 1. So our 10th week since the Christmas exams and the Christmas holidays, and hopefully our last week, so our last 2 lessons before our Easter holidays and before we get to go back to the lab finally, which I'm very, very excited about. So what we're going to do, we're going to keep going with measurements, right? So last week we did some length, and we did some area and volume, and we did some time, and we did some mass. This week we're going to move on to 3 more things. We're going to move on to look at density, speed, and acceleration. Again, I'd rather you were calculating density and speed and stuff like that around the lab with all the different equipment, and we will do that. But for now, we're going to stick and try and get as much of the theory bits of it done as we can. So if we have a look there, I've put up some notes, and we'll go through those quite quickly, right, together. And then I've put some questions down the bottom for you to have a go at. I'm just trying to see, will this sync? It will. Okay, great. So a definition of density is the amount of mass. So the amount of mass in a particular volume. It's kind of a mouthful, isn't it? But again, density has units. So do you remember mass was grams, volume was centimeters cubed. So the easy way to remember density is grams per centimeters cubed. So how many grams, how much mass is in a particular volume? So how much weight have you got in a particular space? So if you want to find density, you need 2 things. You need a mass, your weight and a mass balance, and a volume. So the way you put that into a formula is density Jenny, the pen isn't working great at all. I'm having all sorts of is mass divided by volume. So we get a mass, we get a volume, and we divide the volume into the mass, and that will give us our density. So it's not great syncing there, but we get the idea. That's how we calculate density. So the kind of questions they give us on this then, if we have to calculate the density of a rock, well, they have to give us 2 things, don't they? They have to give us the mass of the rock, and they have to give us the volume of the rock. So we say, right, the mass they're giving us is 270 grams. And the volume of the rock from the experiment is 54 centimeters cubed. So what we do is we use our our formula, mass divided by volume, and that gives us 270 divided by 54, which is 5. So if we want to find any density, we divide our mass by our volume, and that will give us our density no matter what the density. So we can calculate the density of a rock, of a glass of water, of anything. Once we know the weight, the mass, and once we know the volume, how much space it takes up. Okay, bit about that, bit about flotation then. So why stuff floats on other stuff. So why, if you throw a little tiny pebble into a glass of water, it sinks right to the bottom. Yet if I get a massive big ship like the Stena HSS and I chuck it into the water, it weighs hundreds of tons or thousands of tons of steel and cars and all sorts of stuff, and yet that floats where my little pebble won't float. The reason being is because less dense substances float on top of more dense ones. So if I have a glass of water and I add some oil to it, the oil will float because it is less dense than the water it's put into. The density of water, we say, is 1 gram for every centimetre cubed. So if I have 1 centimetre cubed of water, it's going to be 1 gram. If I have 100 centimetre cubed of water, it's going to be 100 grams. If I have 1,000 kilos, it's going to be in a metre cubed. That's how much of a metre cubed of water would be equal to 1,000 kilos. Water expands when it freezes. If you ever try, you bring home a bottle of Diet Coke and you say, right, I'm going to throw it in the freezer and get it nice and cold for when the RTE movie starts on a Saturday evening. What could happen if you forget about it, that the water in the Coke will expand and the bottle will burst. So ice will float on water because it's less dense than the water. So with less dense, it floats. So if you have a metal ship, here's an example here, that will float because the density of the ship is less than the density of water. So you think of a ship, yes, all loads of metal and wood and whatever else a ship is made of, but a lot of the stuff inside the ship is empty space. Think of the old Titanic. What happened to the Titanic? Huge, big, heavy yoke, but it floated on water until a big hole came in the side of it. And then the water got in, the density of the ship rose because of the water, and that's why the ship went down. Okay, and that's the key there. The volume includes the air in the cabins. If you put a ship in salty water, it'll float even better. That's why ships float better in the sea. It'll float better because salt water increases the density of the water. So you have more dense water, means the ship becomes less dense, and it can float higher in the water, right? And we'll answer some questions on that in a while. All the answers are in the notes there for you. Okay, the second thing, and this is a short video today, I'm just doing 3 things: density and flotation, speed and acceleration. So we'll be calculating different speeds as we go along back in the lab. So down to have a look at speed for a second. So speed is how far something travels in a particular time. So we might say a car is going at 80 kilometers per hour. That means that the car is going to travel 80 kilometers in an hour. If we go down to something smaller and we say it's 80 meters per second, that means every second the car is going to go 80 meters. So the definition for that, the speed of an object is the distance it travels in a particular time. So it could be 80 meters per second, it could be 6 meters per second. If we think of Usain Bolt, who runs 100 meters in 10 seconds, that means he travels 10 meters per second, 10 meters every second, when he gets 100 meters in 10 seconds. If we want to find the speed of something, how fast something is going, when you start driving and you get to the port tunnel and there's a little camera at the start of the port tunnel, and it says, and it registers the time you pass. And there's another one at the end of the port tunnel, and it registers the time. And they can work out your speed because they know the distance in the port tunnel is about 6 kilometers, say. And if they have the time, if they divide the time into the distance, they can work out your speed and they can figure out if you're going too fast. So that's your formula there that you need to know. Speed is equal to distance divided by time. So with density, we needed to know the mass and the volume. For speed, we need to know the distance and the time. You might remember that everyone seems to have done this in primary school, and we do it in maths as well. Distance, dad's silly triangle. If not, we can go through it. Distance, speed, and time. So we can work out, if we're given distance and time, we can work out speed. If we're given distance and speed, we can work out time, and so on. We're measuring speed. You're kind of used to kilometers per hour. So we can measure speed in kilometers per hour, but from a lab perspective, we're not going to get people running in kilometers per hour. We're not going to see how many kilometers you can run an hour. We're going to be doing more things like how many meters per second can you run. So I get you to walk from one end of the lab to the next, to the far end of the lab. See, right, how far have you gone? How long has it taken you? And then we can work out your speed by doing distance divided by time. Okay, here's an example question. It keeps doing that every time So you'll notice that the writing is a bit funny. I've had to stop using the app because of the storage for some reason. But we'll get there. Only 2 more classes to do, so I can ditch it after that. So, sample question. A man walks 450 meters 450 meters in 3 minutes and 45 seconds. 3 minutes and 45 seconds. What's the speed? We say, well, how many seconds are in 3 minutes and 45 seconds? Well, in 3 minutes, there's 180 seconds. And then, of course, the 45 seconds. So we're going to have 225 seconds. That's going to be our time. So we've worked out our time. So we now have our time. What we need is our distance. Well, okay, the distance they've given us is 450 meters. So all we have to do is 450 divided by 225, which gives you 2 meters per second. So that's how fast he's going. He is going 2 meters every second, which is about a walking pace. You might go up to 8-9 meters per second if you're in a nice quick jog. The other one I want to do, and you can watch this over again if you need to, and the last one I need to do is this one here. It's acceleration. You've heard of acceleration. People buy a Bugatti Veyron or one of these mad cars, and because they go from 0 to 60 in 6 seconds, this kind of stuff. And that's what acceleration is. So acceleration, by definition, is the change in speed or velocity in a particular time. So it might be from 0 to 60 in 6 seconds, or it could be that you're going from 0, from standing still, to 6 meters per second in a second. So it depends on how quick you're going. Are you standing and you're running away quickly, or are you just starting to walk? So acceleration doesn't have to be a supercar going from 0 to 60 kilometers per hour in a couple of seconds. We said that speed was meters per second. Acceleration is the same, except there's a squared on it. And we'll do, in second year, in maths, we start off looking at calculations around distance, speed and time. But it's much simpler in science. To find the acceleration of something, you get what's the final speed, the final velocity. Take away the initial velocity, what you started off with, and then you look at how long did it take for that change. So we'll do an example quick, right? So a car driving at 20 meters per second, so the car started off at 20 meters per second, hit the accelerator, and ended up at 35 meters per second. That took 3 seconds. So to go from 20 to 35 took 3 seconds. What's the acceleration of the car? So we keep in mind, we get our final speed, what do we start off, or what do we end up with, over our initial one, over how long it took for that change to happen. So what we do is we say, right, well, what's the difference between 35 and 20? 35 and 20 is going to be 15. Well, I'll write the whole thing out for sure, why not? So here's our final velocity. Take away our initial velocity, all over, how long did it take? 3 seconds. Whoops. Okay, so let's work that out then. That's going to be 15 all over 3, which is equal to 5 meters per second squared. And that's our going to be, and they have that there in the answer for you as well. I forgot they actually worked it out. There it is there. Okay, so there's our acceleration done. Now, what I've done here is I've put in a good few questions for you, okay? So there's ones on density, ones on speed, and ones on acceleration. There's a couple of graphs here that I want you to take a look at. So these, a lot of them are out of the notes. What's density? What's the unit for density? Why does oil float in water? All straight out of the notes. And a couple of calculations for you to try. This one here is a cool question. They ask you to find the density of the metal in this ring. When you find the answer, it should be equal to one of these answers. You can tell by knowing the density, what's the metal in it. Okay, so all quick answer questions. It looks like a lot, but they're really quick answer questions. Speed the same. A lot of definitions straight from the notes, and then a couple of questions using the formula to see can you work out the speed speed that something is traveling. There's also ones there, how fast did you travel, how long will it take. So you're going to mess around with the formula to try and work out a few of these questions here. This one here is a graph showing someone going in a cycle. So they start here, and after 2 minutes and 4 minutes, and see how far have they gone. So after 4 minutes, they've gone, after 20 minutes, they've gone 4 kilometers. After 40 minutes, they've gone 8 kilometers, and so on. And you're asked to work out a couple of questions based on the graph, so it's called a distance time graph. Another couple of questions on acceleration. There's a lot of questions there, but they're all really, really short, all a couple of seconds each for you to work out. And then one on a speed time graph as well. And there's a couple of questions on that. So enough to keep you going. The video is nice and short, so you have the rest of the hour to work through as many of those as you can. I don't want you to do more than an hour. I'll correct all these in our live lesson later on in the week. So if you get, say, some of you get all of them done, I know you will, because you'll work through these really quickly. But I don't want you panicking about them. I don't want you spending hours and hours and hours doing them. I want you to do it within the hour of the lesson. This is only a short video, so you should have time and get as far as you can within the hour and leave the rest until our live lesson later on in the week. The other thing I want you to do is I want you to remember the SciFest. So I want to chat about this in a live lesson. So our live lesson will be about correcting the questions from this folder here on density, flotation, speed and acceleration. But I also want to have a chat. What's your ideas on SciFest? What kind of project are you going to be doing for our SciFest competition in May when we get back to the lab? Any cool experiments that people are planning, and hopefully start putting you into groups. Okay, so you can finish up here, and you can start on those questions, and we will get back to it later in the week. Okay, any questions in the meantime, of course, just email me and ask. And have a good week, everyone. Mind yourselves. Bye bye.